I'm recording this video because it is a prerequisite to finish this specialization, Advanced Data Science with IBM. Then I have to show two presentations really. One for stakeholders about my project, and another one, and the other one with more details to possible peers. Then the idea is to show a presentation in PowerPoint and show the Jupyter notebook that I had to prepare for the project. Then let's start with the presentation to stakeholders. The idea of this project is to do a model, to do a classifier to detect fraudulent credit card operations. This is the agenda. I'm going to show the data set, the use case, what I aim to do, and the solution to the use case. And let's go. The first item of the agenda, the data set. It's a data set, it's a popular data set that is available at Kaggle. Then you can go there and download the data. It's related to credit card transactions, and these transactions are labeled as fraudulent or genuine. I'm going to show you it's an unbalanced data set. We have more genuine operations than fraudulent. It's a good sign. Then the idea is to model algorithm, a classifier, to identify these fraudulent credit card transactions. Here I've plotted some features. I performed a PCA operation, dimension reduction operation, to make possible to plot it in R3. And the solution was addressed in a Jupyter notebook that I'm going to show you in more details in the next moments. Okay, this is the second presentation, the presentation to peers. Then my idea here is to show what is the agenda, and this agenda is going to be covered at the notebook, the Jupyter notebook. I used IBM Watson Studio to do this project, and every part of the agenda is going to be covered there at the Jupyter notebook. Then let's go. Open my Jupyter notebook. Then here it's the data set. Then here I have the notebook, the Jupyter notebook. I use the lightweight process model available on IBM. Then I follow these steps. The first step is to take a look at the data set. I did some operations. Here you can see a data frame with the features and the classes. The features are PCA features, then V1 to V28 is a PCA feature. I don't know what is this information, but we have here the amount of each transaction. Then I use it to obtain some tips, some informations. The time during the beginning of the registration of this data set, and the each row operation, and the classes. Here I perform some functions to to count null values and to take a look at the data set. As we can see here, we have a very unbalanced data set, more than almost 300,000 good transactions and only almost 500 transactions, fraudulent transactions. Then it was a challenge during the project. Then I performed these checks. As you can see here, there is no null values in any feature. Then it was not a problem to address during the project. Here I've plotted, it's not showing, I'm run this cell again. Then I've plotted a box plot and a histogram to show the distribute is not running. Then here I plotted a histogram and a box plot to show the distribution of amount at each transactions. As you can see here, the majority of the operations are below. As you can see here, the majority of operations are below 350. Then this was the first step that I did, a data exploration, exploration of the data set. Then the next step was the ETL. I did a simple ETL. The data set has no problems related to no values. It was a CSV. Then there wasn't so much job to do here. Then the only operation that I did was a vector assembly, where I used the feature columns to vectorize the output column features. The next step is the model definition. Here I have chosen some specific models. One of them are the GBT classifier, gradient boosting. It's a powerful model, and I think that is going to perform well. It's performed well, really. Linear SVC and a deep learning model as requested in the project. Then after this definition, I did some preparation to ingest the data in each model. The next step was the model training. Here I trained each of the models of the algorithm, the gradient boosting, linear SVC, and the deep learning, the Keras model. Then step 6, model evaluation. Here I used area under rock curve as the metric, because as I showed previously, the data set is very unbalanced. Then I choose this metric. Here I did the evaluation at the train set. Then I did this evaluation to test set. And during when I evaluated the train set, I was worried about the result, 100% of accuracy or AUC. Then it could indicate a overfitting. After this, I did the evaluation on the test set, and the power of generalization of this model was good. The same I observed at SVC. And Keras, the deep learning model, sequential deep learning model, it was a good result too, but not so good the two previously mentioned. Then step 7, model deployment. I tried to use the Watson Studio to deploy the model, but I had some problems related to the TensorFlow version. Then I decided to deploy it in this notebook. Then here I step 7, model deployment. I decided to deploy the model in this notebook. Then it's here the result. In this first cell, I try to find rows or index with fraudulent operations to evaluate the models. My Keras model was not able to identify fraudulent transactions. As you can see here, the answer should be 1, a fraudulent operation, and here the vector with probabilities indicates a 0. The high probability is to a good transaction, and it's not the case. And it happened for almost 100% of these operations. Then this model didn't work. Then I did some queries here in the predictions data frame that I created here related to SVC, and as you can see here, it worked very well, this model. I calculated true positive, false negatives, and true negatives, and the result was very good. Every fraudulent transactions was identified, and every good transactions was identified too. Then it represents a good result. The same for GBT. Then it's all. Thank you. Here is the project for my IBM specialization.